Welcome to the Jerich Show, featuring your hosts Javvad and Erich. Timely topics, poorly presented.
Hello, everybody, and welcome to the Jerich Show. As always, I am Javvad, and finally, my prayers have been answered. Erich cannot make it today, so I was going to replace him just with a photo of a potato. But then I thought, well, why don't we go out to our extensive security community and find someone who is far better looking than Erich, who is far more competent than Erich, and who can teach me and all of you a few things about security. So I went and found Mr. Mohammed Aldoub, who is a security researcher and professional from Kuwait. So welcome to the show, Mohammed.
Assalamu alaikum, Javvad. How are you doing? Welcome to the show. Thank you for, I'm the second host instead of Erich, so I might as well welcome myself. I wish Erich gets well and joins you in future podcasts, especially since you're the mascot and you can't do it without Erich. Last time I heard.
Oh man, see, this is a classic example of American propaganda reaching the Middle East, and he's been telling you that I'm his mascot, and okay, if you want to believe that, that's fine. So anyway, despite your very, very young looks, you have been working in security for quite a while now. So just give us a brief background, like how did you get into security, or what made you choose security as a profession?
My experience in the field of cybersecurity is almost 11 years. I started working in Kuwait government, and I started to work fresh out of graduation into the country's national authentication gateway project, which was a government project in Kuwait to utilize cryptography, smart card authentication, to enable citizens and people to log into online services using their smart cards, which contained cryptographic keys. Also be able to sign documents, sign contracts, and that work extended to other fields of cybersecurity in terms of penetration testing, security of applications, AppSec, and then extended to the world of cloud security. So now I'm focusing mostly on API and cloud security at the moment, especially in terms of application security and in terms of cloud security, specializing in AWS security.
Oh wow! So that's quite an interesting field. I don't think I've met many people that are such specialized or experts in API security, particularly around cloud components and what have you. I suppose, is there anything in that space that you feel that is lacking? Because a lot of people, they just leave it to the cloud providers. They're like, well, if Amazon have this product, I just need to connect to it and leave it all to them to sort out. Is that something that you think that is a misconception? Do you wish more security people were more heavily involved, or is it just a specialist field that you only need a few people?
Well, it's better job security for me if not everyone got involved in this. But actually, if you think about it, cloud security is all about API security, because the way to talk to your cloud provider is through APIs. What I'm talking about is actual production work in the cloud. So in real production environments, for example, using AWS, using Azure or Google Cloud environments, they don't really depend on employees or administrators going to the web UI of the cloud provider and then configuring things. They actually do it using APIs at scale, using automation. So API security and the cloud security are very much integrated together. They're in the world of APIs, they're the same thing essentially. And in terms of API security itself, it's interesting because it links two worlds that, for lack of a better word, hate each other. The front-end people hate the back-end technologies, and the back-end people hate the front-end technologies. And what links them together is the world of APIs. So front-end developers tend to sometimes misunderstand back-end technologies, and vice versa, back-end developers or administrators tend to not very well understand the front-end technologies. So the link between them, the API world, would contain lots of confusions, wrong assumptions, and herein lies lots of vulnerabilities because of this, let's say, layer of confusion between them.
I think you make a really valid point there, and this is something that I think has been the core of a lot of issues in security throughout the years. Even now, you see some products that are out there on the market, and they're like, well, this can do this for you, but they don't actually take into account the impact it has on everyone along the way, even to the end user. So sometimes you'll see things like, I don't know, I mean, going back a few years before soft tokens, there was hardware tokens for all MFA. And sometimes you'd have to carry like 2 or 3 of those around. And so logging onto something was a real pain. And then if it was a shared admin account, then you had to share the token as well. So there's a lot of impracticalities that sometimes come into play when someone designs something in isolation. Now, speaking of API and cloud security, one story that was recently in the news, and it's been making a lot of headlines, is the breach or the exposure over at the new social media app that's been taking the world by storm, Clubhouse. And there was like a lot of things. I mean, there's a lot of privacy, obviously, issues around there, because people are like, well, these conversations were meant to be private and now they're not. And then other people are saying, well, if you're using a public platform, you shouldn't expect privacy. But putting privacy aside, from a security point of view and from an API point of view, you actually shared with me. Sorry, let me just bring up the window, and if I can find the right tab.
Slow machine, I guess.
Yeah, no, it's not. I'm on the wrong tab, aren't I? So this one, Daniel Sinclair, he looked a bit at this. You're far better at explaining this, so why don't you talk us through what's happening here in Clubhouse, in their API, and why this is such a mess.
Okay, so this is a Twitter thread by Daniel Sinclair, explaining the issues that were discussed in the Clubhouse API. Of course, adding to your point, it is true that even though Clubhouse would like to promote this as enabling both private and public communication, it's just that difficult for me to guarantee to someone that they can have a real private conversation in using such an application, because anything can be recorded. And the samples we've seen with people using or creating their own custom client side application for Clubhouse to record, for example, the conversations and things like that. That's not the real issue, even though that's an issue that could happen in any application. You could talk to someone through WhatsApp, for example, and then they can just start recording the conversation. That's not the real issue. The real problem with the Clubhouse is that the layers of technologies used inside Clubhouse are so disjoint that it was really difficult for Clubhouse to integrate them securely together. What happened is that Clubhouse had their own internal application API for user management. For example, someone registering, someone following, someone logging in, logging out, following people, seeing your follower list, for example. That's the Clubhouse user management API. And then there's the actual voice call API that is used for the actual conversations, the actual voice conversations happening in Clubhouse. That was used. They used the Agora platform for the voice APIs using the RTC technology, real-time communication. So the Clubhouse application used the Agora API to utilize or to start these sound channels, or I could say sound calls, which are essentially the channels or the rooms inside Clubhouse. So now we have two separate APIs, the Clubhouse API for user authentication, for user actions, and then the Agora API for the actual data channels themselves. The problem is the connection between those, the integration between those two APIs was not done correctly. So what happened is that you could get a token for the Clubhouse from the Clubhouse user API, and a separate token from the Agora audio channel RTC token. So the Agora channels using the RTC technology used for audio give you a different token from the token by the Clubhouse user management API. And if you changed your user management state, for example, you joined a channel, you left a channel, you logged off, or whatever, the Agora token itself is separate from the user token. So you could leave a channel and still obtain a token that allowed you to listen to that channel. Or if you've been given access to talk in a public channel, and then somebody removed that access from you, so they sent you back to the listening row, so you're not a speaker anymore, the token you got from Agora that allowed you to speak in the first place would still actually be active and would still allow you to talk. So this created some sort of a ghost speaker situation inside Clubhouse. You could, if you get promoted to talk, and then someone took away that privilege from you, the token that you have gotten from Agora RTC that allowed you to speak in the first place will still allow you to speak, even though you were demoted by the channel owners. So normally you should not be able to speak anymore, but because you obtained this channel, you obtained this token, the Agora token, which is, as I said, disjoint from the Clubhouse API token, the Clubhouse user management API. Now you can use this one to talk or to listen to channels that you should have not been able to listen to or to be able to talk into in the first place. So that's the short explanation, even though I made it longer than it should. But the idea is you have disjoint layers of technologies not talking to each other correctly, and that's the actual fault that Clubhouse made.
Right. So is there a simple way to fix this? Is there a way to simply to get the two tokens to integrate better with each other, or is it a complete re-architect?
The problem, I think, is Clubhouse depended a lot on the application, the client-side application doing the correct actions. What I would have done instead in place of Clubhouse is that I would have unified all of these tokens into a central token retrieved by the Clubhouse API server. So the actual client, the phone app, would receive and would utilize a single token. And in the back end of Clubhouse, I would do the management correctly of the Agora tokens and the rest of the API features inside Clubhouse API server, such as, for example, the management of the users, the management of who joins a channel, who gets privilege to speak, and who gets demoted back. So the Clubhouse API server would handle that instead of depending on the client-side application to do that properly. Because if you read the analysis, one of the points mentioned was that the Clubhouse API server would send a notification to the application to leave a room, for example. But the client-side application, especially if it's reverse engineered by someone, they made a third-party client, can just simply reject that request and stay in the room entirely, not have to honor the leave request from the API server of Clubhouse. So that's one way I would solve it: centralized API management in terms of in the backend completely by Clubhouse, and the client side would only talk to one API source.
Excellent. Thank you for that. And Clubhouse, if you're listening, you're welcome. I just got you a lot of free advice on how you can fix your architecture, and maybe some other platforms as well. So let's move on from Clubhouse, because I think that's been done to quite a lot, saturated the market quite a lot recently. There's this story that you sent this to me, and this is from last year, but I think it's a really interesting one in the context of the topic that we're talking about today: API security and cloud security, and how they're so tied together. And this is a blog written by someone, Sam WCO, WCYO, and they have some examples of, like, API calls that they're examining that's going on within Starbucks. What's going on with this story?
So this was research done by I think Sam Curry. I hope that's the way to pronounce the name correctly. What they found out was that Starbucks API was utilizing something that we can call backend for front end, which is a fancy word for a proxy. Essentially, it's an API proxy. So the API, the Starbucks API, was sending these requests to this backend proxy, which would proxy that request back to an internal application server. So in the image that you're showing in the diagram here, there is an internal network in the middle, which is like the proxy line, which takes the URL that's being proxied, and then depending on the URL, it will be able to direct the request to the correct backend API, sort of like how we do it with Nginx, for example. So it's a very, let's say, standard way of redirecting requests internally. The problem with this one was that the attacker was able to find a way to call another API by changing the URL of the backend itself. So instead of calling the regular backend, they were able to call and find the internal URL for a different backend, which they found upon trying to guess different URLs, different paths. They found an internal API that was being proxied, which sent them to a Microsoft Graph application endpoint, which allowed them to query, I think, more than 100 or almost 100 million Starbucks customers, production customers, Starbucks customer addresses, and be able to query them as if they were sitting in front of the database directly. So what was going on is that the proxying for the backend API was done incorrectly. They found a way to traverse using path traversal, traverse the backend and go to a different backend than the one that was expected by the developers of Starbucks. So that's, remember when I said that APIs link the backend and the front end, and in this integration, some confusion happens, some wrong assumptions occur. And this is just one example of that. The developers thought that the internal API was really internal and really private, and it was not supposed to be called from outside. However, the researchers in this case were able to utilize path traversal tricks to switch to that internal API and then call it directly from the front end endpoint.
Yeah, fascinating stuff. Once you start looking at all the APIs and how they operate and what have you. So is there a quick fix for this kind of routing error? Is it just, can you just put in a rule that stops you calling a different application?
Well, it depends. If I were in a place of Starbucks, I would say, do I need to have those internal APIs also exposed for the proxy, or should the proxy be able to only proxy requests to other public APIs? So that's one way I would look at it. The other way is that I would try to fix the path traversal behavior in my proxy itself, such that it cannot allow someone to traverse out of the path that was supposed to be set by the application. But of course, that's easier said than done, because this is probably a legacy application with lots of difficult, let's say, decisions made in the development and deployment. So it's not always easy to unwind all of that mess and make it as straight through as you would dream to have.
Yeah. So that brings a really interesting question up, and just taking a little bit of a detour here. But it's very easy if you're a new company that's only ever had cloud applications and you've been born in the cloud, so to speak, that you can architect things in a certain way and you can develop things in a certain way. But many organizations are old and they've got lots of legacy applications that they do need connecting through some sort of cloud interface in some way. And they don't have the capability to bolt on certain things, or they're too scared to make too many changes to it. Is there just a general way that you found that works well, or are there some things that people trying to connect to legacy applications should bear in mind that will help them secure the process? Or is it really a case-by-case basis depending on the application?
Of course, it definitely depends on the application, because lots of legacy applications nowadays actually have versions for the cloud. So for example, things like Oracle, SAP, some of these applications have actual supported updated versions on the cloud. So someone could just simply use that. But of course, it depends on the type of application or type of infrastructure. I would, if I was tasked with that, hopefully I will never be tasked with such a horrible task. But if I was ever tasked to do that, I would try to do it manually, trying to start with the easiest stuff first. For example, moving my services bit by bit until I can be sure that the migration has been done correctly. And this is a chance to say that not all applications, not all organizations actually do need to migrate to the cloud. The cloud is not for everyone if they don't understand it. What I'm trying to say is that if you use the cloud exactly like you used your regular infrastructure, then there's no point in going to the cloud. If you're using AWS or Azure just to rent VMs and run them separately without using any of the technologies of the cloud provider itself, then there's really no point to go to the cloud in the first place. You're just moving your VMs from your data center to AWS without utilizing any of the automated and cloud native features inside AWS or Azure or another cloud provider. So the point is, it's not to move your work from the cloud. It's to re-architect it such that it works seamlessly with the cloud in a cloud native way. This is the only way for you to actually reduce costs in the cloud, actually make things easier, actually be able to handle and automate most of the boring stuff, most of the needless, busy work that we used to do in regular environments. One example of that, I've seen a use case for a web application. It's a training company that used to have training about cloud topics. And I read that their EC2 monthly bill, EC2 server is the virtual VMs, virtual servers of Amazon Cloud. So their EC2 monthly bill was in the thousands, like $30,000 US dollars, for example, every month, because they're running all of those VMs. So they decided to actually utilize cloud technologies of AWS. So they utilized, and then they did a migration to AWS Lambda, which is Amazon's function as a service. So instead of hosting full VMs inside Amazon, they cut their code bases into functions and then let Amazon deploy and serve these functions independently. They were able to reduce their bill from more than $30,000 per month to less than $1,000 per month. So that's an amazing reduction in the bill. Of course, it's also an increase in complexity. Lambda is not really easy to work with if you have a big number of Lambda functions. But it's one trade-off that I'm sure many organizations are willing to take in terms of the cost. But that's one benefit. You go from actually using the cloud the way it was meant to be used, not just taking your metal servers and then replacing them with virtual servers in Amazon. That's not the way to utilize the cloud. Even though there are benefits to that, you're missing more than 80 or 90% of the actual benefit that you could have achieved if you actually used the cloud native features in the cloud and the APIs of the cloud itself.
Yeah, no, that's a very valid point. And actually, though, even figuring out pricing on something like AWS is not very straightforward. There are people who are actually cloud economists, for lack of a better term, who actually spend a lot of time trying to work out what the price is of, and because like everything's customizable and there are so many different options, it can get overwhelming. And there are actually some companies, like the one that comes to mind is where Corey Quinn works.
Corey Quinn, yes.
Yeah, Quinny Pig on Twitter. Yeah. Here it is. I've got it.
It's the Duckbill Group.
The Duckbill Group. That's exactly it. This one, yes. So their whole job is to help you understand your cloud consumption and reduce your bill, I suppose is the way to do it. And
It's a complex world inside Amazon, and the billing system inside Amazon is the most interconnected system inside Amazon. So because it bills for everything by the second, by the hour. So understanding billing by Amazon is really complex, really difficult. And that's because the cloud is just so complex and it solves so many problems, but only if you can let's say accurately describe your problem and be able to understand what are the actual solutions and how they can benefit you inside the cloud. The same thing applies to the issue of API security. Lots of problems occur because of the missed assumptions or misunderstandings that are happening in terms of the cloud world. So in the world of API security, for example, one of the main issues that developers or organizations face is how can they, whether or not they are conforming to the standard correctly. For example, most APIs utilize the REST API standard, and by trying to conform to that standard, there are certain rules that you need to be able to follow properly. And if you don't follow them, they're not actual rules, more of a guideline. But if you don't follow the guideline correctly, you know what I'm talking about. If you don't follow the guideline correctly, then you will not, you might have issues where the assumptions are going against you. And I have an example here. I think I'm gonna try to share my screen to show you the example. It was a really interesting example in Drupal. Let me just share my screen. So this is, where do I share? That's the one.
Then it should show up, and then I could.
Okay, so where is it?
So
this vulnerability in Drupal. So Drupal is a PHP-based CMS, and in the REST module, in their API REST module, one of the functions that should have only received requests using post or patch requests, like the verb get, post, put, delete, patch. All of these have different meanings inside REST APIs. So for example, get should mean that you only read data, you don't modify data. Post is used to create a new object. Put is to update an object fully. Patch to update an object partially. Delete to delete an object, for example. So in this case, the REST API module of Drupal CMS, which is enabled by default, I think. If you enable the REST module, the API module of it is enabled. So in this module, they noticed that there is a deserialization vulnerability. However, the best practice of Drupal says that if you don't need such features, you should just disable them or disable the post and get patch verbs. However, the researcher found that you could still send a GET request. However, you could also send a body in the GET request. Now, normally, GET requests should not be sent with a body. They should be sent with a query parameter only, like this one. So you put a body in the request when you send a post or patch request. You don't do that when you send a GET request. However, what they found out was that the Drupal API accepted body request bodies in the request, even though they're using a GET type verb. So the researchers, upon doing more research, they found out that even though they can send unauthenticated GET requests, they can send payloads which contained serialized content. So they try to use some popular PHP deserialization attack tool to generate payloads for the deserialization, and then they sent it via GET request in the body of the request, which should not have been done in a GET request in the first place. So Drupal should not accepted this behavior in a GET request. Unfortunately, Drupal was vulnerable to this serialization vulnerability, and because it was sent in a GET request, not a post or patch request, it was not expected by the Drupal developers. So this type of assumption in the API resulted in this feature not being properly analyzed. You remember how you read in history about a big city or a big fortress, being lost or conquered because the invaders found a small, teeny tiny hole in the wall somewhere. That's what happens when you don't standardize your applications and don't document everything in your application. That's what happens when you have wrong assumptions and confusions in your API layer. So attackers find this small hole through which they get through to your application. As the example I just showed, there's also another example. I think it's also interesting. Let me share my screen again and show you the other example. I think it's this one. Yes, it's in a HackerOne report. I think one of the applications Helium. So in Helium console, you could query group membership using their ID, for example, ID1, ID2. And then the researcher found out that they could query or send the delete request, a delete request in Burp Suite, for example. This is a delete request. So if you check the screenshot to the left here, a delete request is just like a get or put or patch request. The developers of the API did not expect a delete request to come at this endpoint, but the module for the REST framework and their application actually accepted the delete request and deleted the user or the membership with the ID explained or requested here in the request. So another instance of an API not really understanding all of its assumptions, all of its features that are enabled without them knowing about it. So that's one angle of the API security that people tend to ignore.
That is truly fascinating stuff. I've learned so much. So if there's anyone out there who wants to take the first step to learning a bit more about API security, cloud security, whether they're completely new or whether they've been doing traditional security for a while, what would you recommend them do? Well, other than sign up for one of your training courses, because you do training courses as well. Let me just pimp out. This is your GitHub page, yes. And so you have some of your tools here. You have a training schedule, which you say needs to be updated.
Yeah, because my next training is in May in Black Hat Asia in Singapore. It's online, virtual, but it's based on the time zone of Singapore. So it's going to be in I think May. Yes, May. I don't remember exactly which dates, so I'm going to post it in my GitHub and my Twitter account. It's in Black Hat Asia training list if someone is interested. And to your question, if someone wants to learn about API security. Now, the problem is API is not a separate world in or of itself. So if I wanted someone to learn properly about API security, I would say learn the technologies well that are being used inside APIs. So, for example, learn and especially how to use them security, the technologies that are used inside APIs for authentication authorization, for example, OAuth, OAuth2, OIDC, the technologies used to perform authorization and identification of users, and also learn about the session handling and session management that are being used inside APIs. For example, learn about JWT. What does it mean to use JWT? What is JWT? What are the problems with JWT? And especially, the topic of JWT is very interesting because it is extremely difficult to understand JWT very well these days and try to distinguish the bad practices from the good practices, also trying to distinguish the bad theory in terms of the world of JWT. For example, the standard of JWT itself, if you follow it verbatim, you will fall into security problems because, for example, the standard of JWT mandates that you should allow signing your tokens with an empty algorithm, which means it's like signing a blank check. You don't have to sign anything. So this is one of the major problems in JWT. I think one of the main problems in JWT, which of course stands for JSON Web Tokens, is that people think JWT is a session management technology of sorts, or an authentication technology of sort. People say JWT versus cookies, for example. That's a wrong comparison. JWT is not let's say authorization or a session technology at all. JWT is actually just a data format. So if I wanted to compare JWT, I would compare it with, for example, XML. So JWT has JWT signing encryption. XML has XML signing encryption. It's just a way to format data such that you can put your data inside it in a certain way. People use JWT to put user data, for example, user sessions or user IDs, and then sign these JWT tokens, and then utilize that signed token because they think that because it is signed by the server side, then it means that whatever inside it can be trusted. Of course, that's a problem if you think about what happens after you issue the session. You want to log someone out. So if you log someone out, how can you differentiate between that person's session and the other sessions for other users that were signed using the same key? How can you invalidate a certain session by itself? You cannot change the key because this will mean invalidation of all the currently logged in users. And if the logged in users know your address, they will come to your address very angry, carrying pitchforks, right? So people would say, you know what? Okay, let's put a black box API for deleted or expired or suspended, not suspended. What was the word I'm going to say? Rejected tokens. So if I log out, they should try to invalidate my token, invalidated tokens. So put an API or put a database of sorts where you can just store the invalidated tokens inside it. And anytime someone logs in or sends you a token, you try to look up the token. If you think about it, this is exactly the same thing as we were using with session IDs with cookies before. We were using a database to look up the sessions and then check the details of that session ID, if it is expired or not, which user does it belong to or not. So that's the same thing being done here if you think about it properly. So the problem is people started using JWT thinking that it is comparable to cookies and sort, even though cookie is just a special header in the browser and JWT is just a data format. So they are missing the actual problem itself. The actual problem is, how can I put or create a proper session management system? In my opinion, a proper session management system should use non-predictable random session IDs, and then you can put these session IDs in whatever format you want. You want to put the session ID in JWT or in a cookie or a separate header. It doesn't really matter as long as the session ID looks up a user properly on your backend system. That's the actual goal that you want to obtain, because one way or another, trying to put the effort of authenticating your users solely on JWT just because it can be signed is a great way for you to create lots of wrong assumptions, which will potentially result in lots of problems for you in terms of security down the road. So understand the technologies well, understand the limits of the technology that you want to use, understand how they get integrated into each other. Then it will be easier for you to understand how the components, like the mobile app, the single page application, talk to the API in the backend. And also APIs are not just client to server communication, they're also server to server communication. So a function on a server will call a function on another server, for example, sending serialized objects. So that's a venue for serialization attacks. In other words, in terms of the world of API security, always understand the technologies that are talking to each other, and always understand what are the expectations for each of these technologies and how they can be attacked from both sides, from the client side and the server side.
That's fantastic, wise words. I think that mindset can be applied to any aspect of security, and it's one that I think that, especially people that are new to the field, they should really understand the words that you just said and hold on to it, because a lot of it is about like looking at the interactions and just seeing like how can they be abused, or what could go wrong, or is this, what assumptions have we made, and are those assumptions validated, and of course document everything that you do. So it makes it easier for other colleagues when they come along and try to build on your work or integrate something with it. This has been absolutely enlightening. This has been so wonderful. I just, I just feel like I've got a free class on API security without paying for it. So that's a money-saving tip, kids. If you don't want to pay for a course, start your own podcast and invite all the people who would run the course. Cool. And it's been, you are far better looking and far more knowledgeable than Erich. So if he doesn't make a recovery, then you're more than welcome to come back every week and we can have the discussion. I'm down with
that. I'd be honored, and I also take this chance to again wish a quick recovery for Erich, so that he may join you and bother you in future podcasts and put you in your right place as a mascot.
Okay, so that's what I do. When people get annoying, I kick them out of the room. So thank you so much, Mohammed, brother. Jazakallah khair for coming. Thank you, everyone else, for being here. Hopefully next week, Erich will be back. And stay secure, my friends.